Hello and welcome to the webinar today. This is the second part of the Beginners series webinars, and it is about system models. The first part happened 2 weeks ago, and it was focusing on the activities. My name is Dimitra Ioannidou, and I am a project manager at ecoinvent. First of all, some organizational points about the webinar. All of you are in listen-only mode. If you have any question, you can type it in the chat box. I will make some pauses throughout the webinar and I will go through the questions. And if we don't have time to address all the questions, then I will come back with an email addressing these questions. In addition, there are more webinars to follow, more sector-specific webinars. There is a webinar on electricity, the electricity sector, and on oil and gas. If you are interested in these webinars, feel free to register through the ecoinvent website. So now let's start with this webinar, and let's first see what is the goal of the webinar of today. The first aim that we are going to do is we are going to build upon the webinar of 2 weeks ago. We are going to look at the activities and understand even better how they are linked in the database. And based on that, we are going to look at the system models, and specifically the 3 system models: allocation, cutoff by classification, allocation at the point of substitution, and consequential. The 4th system model, allocation, cutoff EN15804, has already been covered in another webinar about the construction sector. So if you are interested in this specific system model for EPDs, feel free to access the recording in the YouTube channel of ecoinvent. And the final point in today's webinar is the modeling of some supply chains and how this changes depending on the selection of the system model. We saw in the first webinar of this series that the smallest element in the ecoinvent database is the activity. An activity is a representation of a human activity. And the activity can be expressed either in unit process, which is a gate-to-gate format, or in cumulative LCI. This is a cradle to gate. If these concepts are new to you, you were not in the previous webinar, feel free again to access the recording of the webinar in the YouTube channel. So the ecoinvent database has more than 19,000 of these elements of multi-output, unallocated, unlinked unit processes. This part of the database is called undefined database, and it is only accessible in EcoQuery. These are the datasets as they are supplied to us by the data providers, and after, of course, they go through internal and external review. These undefined datasets, you can use them to check the modeling of its activity, the choices taken, the mass, carbon, and water balances. Now, based on these smallest elements, these multi-output UPRs, unit processes, the database the system models are constructed by implementing some rules, some linking rules, and some additional assumptions. And based on this linking, of course, the life cycle impact assessment scores are calculated. So let's see these rules that are important for creating the system models. First of all, we have the linking of the activities between each other, because the smallest elements, the activities, need to be linked in order to create the supply chains. The activities are linked either through markets, or the transforming activities are linked directly with direct activity links. Now, using this linking, which is a general rule, let's see what are the specific assumptions that are different in the system models. And first of all, let me explain what is a system model, because I'm using this term quite often now. A system model is a collection of modeling choices made for the database. These modeling choices define how the data sets are linked between each other. So we have three modeling choices that define how this linking will happen. First is how to resolve multi-output activities. In the ecoinvent database, in the different system models, we have either allocation or substitution. When we have a multi-output activity, that means an activity with more than one output, the activity will have a reference product and one or more byproducts. We have two options, either to allocate the activity, to split the activity in two or more, and each of these allocated activities will have one reference product only, or to implement substitution. I will explain substitution in a while. But first of all, let's see about allocation. According to the standards of the ISO series, the first step when we have a multi-output activity is to disaggregate, if possible, based on the physical properties. This is also the first step that we are implementing in the database. When possible, we have physical disaggregation. When this is not possible, in this example here, cobalt production produces both cobalt and electricity high voltage. We cannot physically disaggregate what inputs and outputs are associated with each of these products. So in this case, we will allocate from one activity with two outputs to two activities with a single output each. And in this case, we also allocate the inputs and outputs to the two activities. In the case of substitution, the reference product gets all the burdens, all the impact of the inputs and emissions. But in the case of substitution, we also give credits. The reference product gets the benefit for any byproduct, because if the byproduct was not produced in this activity, there would need to be a primary production elsewhere. In the case of cobalt again, here electricity does not receive any impact, but it is considered as avoided production. Because of producing electricity high voltage in this activity, we do not need to have primary production, for example, produce this activity from a hard coal plant. The second modeling choice is the use of average of our unconstrained suppliers to supply the markets. We can have different cases. We can either have all possible activities that produce one specific product supply the market, or we can have just specific activities that produce a product to supply the market. And in this case, in the second case, it's just the activities, the marginal activities or unconstrained, the activities that have the capacity to produce an additional unit, an additional kilowatt hour, for example. The market composition in the two cases is different. An example here to understand the difference between average and unconstrained suppliers is when we perform a life cycle assessment of charging a vehicle, an electric vehicle. If we perform a life cycle assessment of charging a specific electric vehicle, we will probably use an average electricity mix, which means that the current electricity mix that we have, we assume that it will continue to supply also the kilowatt hours that the charging of our vehicle requires. However, if we have an LCA study where we look at the charging of all the electric vehicles, or we look at transitioning to a fleet where all the vehicles are electric, then we probably need to use the marginal suppliers. These are the suppliers that have the capacity to increase their production and to provide these additional kilowatt hours that are needed for the requirement of our study. And the third assumption when creating the system models is the separation of the life cycles, the end of life. Who bears the burden of the treatment? And here I will show one example with 3 different implementations in the 3 system models. We have the case of furniture production wooden, which produces as a reference product furniture wooden, and as a waste throughout the process some waste paperboard, for example from some packaging. The waste paperboard needs to be treated, and the treatment activity is a municipal incineration activity. Now, if you don't remember this representation of why we have a negative input for the waste paperboard, please look at the first webinar of the series. But just to explain here shortly, in this way, having the waste produced as a negative input, in fact, what we say here is that the furniture production consumes the service of treating the waste paperboard, or that the waste paperboard municipal incineration provides the service of treating the waste paperboard. And this is in order to highlight, especially in the cutoff system models, that the furniture production is responsible for consuming this treatment activity. Now, this treatment activity produces heat. How do we allocate the impacts between the two life cycles, the primary and the secondary? In the cutoff system model, what happens is that we say that the polluter has to pay. It's a polluter pays principle. And for this reason, the furniture production bears the burdens of treating the waste paperboard. The heat coming out of the system is burden-free, and any activity using this heat will not get any impacts from the heat. Now, in the case of substitution, the primary producer bears the burdens of the treatment of the waste. So furniture production again bears the burden of the treatment. The heat that comes out here will be credited. That will be a credit for the furniture production, because this means that we avoid primary production of heat elsewhere. And in the allocation at the point of substitution, this end of life is also different. Here we have a system expansion. We look at all valuable products that come out of the supply chain. So here all valuable products are furniture and heat. And the impact of the supply chain, the impact of furniture production and of treatment, is allocated between the 2 products. And then we have 2 single output unit processes. So if we look at it schematically, we always start from the undefined database, the multi-output unlinked unit processes. And then we implement different rules. These are the 3 points that I mentioned before. Whether we have average or unconstrained suppliers, what is the assumption that we follow for the end of life, how we separate end of lives, and how we deal with multi-output activities. Then, from this undefined database, implementing the linking rules, we get the single output linked unit processes. Here we implement matrix inversion and we get the cumulative life cycle inventory data. This is, again, it's at an activity level, but it's another format of looking at the activity where we have only elementary flows, inputs and outputs from the environment. And finally, we apply the characterization factors and we get the life cycle impact assessment results, which means that from the undefined database, one undefined database, based on different linking rules, we can get different system models and of course different life cycle impact assessment results. So now let's dive deeper into the three system models. And let me first of all look at some questions that we have. So average is attributional and unconstrained is consequential. Correct. The first system model that we are going to look at is the allocation cutoff by classification. This is the system model that is most widely used by the users. Let's first see what are the assumptions for this specific system model. So as you remember, we had three different points that we were looking at in every system model. First point, multi-output activities. We have allocation. Markets, they are supplied by average suppliers, and the end of life is separated based on the cutoff approach. That means we have the polluter pays principle. The polluter bears the burdens of treating any waste and does not get any credit for supplying recyclable materials. Use of recyclable materials in a secondary supply chain comes burden-free. And here, just a quick note, when we are dealing with the cutoff system model, it is interesting to see that the cutoff system model does not promote the production of valuable secondary materials in a supply chain, as the producer does not get any credit for supplying valuable recyclable materials. Here, an example of what this statement practically means. We have an activity producing waste. This waste is called used lithium-ion battery. Let's call it waste. This waste needs to be treated. And from this treatment, we have a valuable product coming out, a recyclable. This recyclable comes out of this treatment burden-free. And then it will enter in a secondary supply chain burden-free. So the activity consuming this valuable product, the iron scrap unsorted, will get it for free. So in this sense, of course, just to make a comment here, the cutoff promotes the use of recyclable materials, since the consumers get the recyclable materials burden-free. The way that we are implementing this in the database is with the classification of byproducts. We have three types of classification: the allocatable byproducts, the waste, and the recyclables. Allocatable are the majority of the products in the database. An allocatable is a product with an economic value. And when a product is allocatable, it receives part of the burdens of the inputs and outputs of the activity. In this case, we have a transforming activity with a reference product and an allocatable byproduct. Since we always need to implement the linking and get single output activities, in the cutoff we have allocation and we have two single output activities. This happens when we have allocatable byproducts. Now, when we have waste, waste is a product with no economic value. The producer of waste needs to pay in order to get rid of the waste. The waste is modeled as a negative input. So a transforming activity that produces waste is consuming the service of treating the waste. In the case of waste, the activity producing the waste bears the burdens of treating the waste. And any valuable product that comes out of this supply chain, out of the treatment activity, comes out burden-free. So the point of cutoff, the point beyond which we do not have any more burdens, is after the waste treatment. Now let's see the example of furniture production that we looked at in the beginning. And let's see how this classification is implemented there. We have the furniture production producing waste. The waste is, for the modeling purposes, is a negative input. So the producer of waste, as mentioned, bears the burden of treating the waste. And as seen in the example before, the heat that comes out is burden-free because the point of cutoff is just after the treatment of the waste. And the third type of products that we have in the database are recyclable products. These are products with low economic value. However, the difference with waste is that here it makes sense. There is an incentive in collecting these recyclable products and using them again in a secondary life cycle. Here again, for modeling purposes, recyclable products are modeled as negative inputs in the activity producing them. In this case of producing a recyclable, the cutoff is directly after the transforming activity because a recyclable does not need any further treatment. It's already ready to enter in the secondary supply chain. So it enters in the secondary supply chain burden-free. An example here, I will use another example so that we can see a recyclable. We have the activity of fish curing, which produces waste, packaging, glass, and sorted. Again, it's some waste packaging glass during the procedure of packaging. This is considered a recyclable. And that means that it does not need any treatment in order to enter in the secondary supply chain. So the point of cutoff is after the producing activity. In the secondary supply chain, it enters burden-free. There is some sorting process required, and it produces glass cullet, which is used in another activity. So what we see here is that the difference between waste and recyclable in cutoff is that in the case of waste, we have the producer getting the burden of treating the waste. This classification between allocatable, recyclable, and waste is provided by the data providers. And of course, there is input from our side, from the ecoinvent side, and also from the editors during the review process. The second system model that we are going to look at today, it's called the allocation at the point of substitution, or else APOS. So here, let me first summarize that the allocation cutoff that we looked at right now was the system model that promotes the use of recyclable materials, does not promote really the production of materials that can be reused, since there is no credit for producing a valuable material. And we look at an attributional system model at the here and now. APOS is also an attributional system model. it evaluates the here and now. The multi-output activities in APOS are treated differently. We have again allocation, but between all co-products. And the markets are supplied by average suppliers. So it is quite similar to the cutoff system model, but the main difference is that the burdens are allocated between the reference product of an activity producing the waste and the valuable products that come out of the waste treatment process. We have an expanded product system. So let's take this and look at it more here. We have an activity A that produces a valuable product A and a waste product B. The product B needs to be treated and produces a valuable product C. We have here the two bars are the impacts, the unallocated impacts of production and of treatment. In the cutoff system model, all these, the sum of these impacts would be allocated to product A, and product C would come out of this supply chain burden-free. In the APOS system model, we calculate the sum of all the impacts in this expanded system, and then we allocate to products A and C based on their economic value. So again, in the example of furniture production wooden, here we have the supply chain as we saw it, that the furniture production produces waste paperboard, and there is the treatment of waste paperboard that produces heat. Heat is a valuable product. And all this is the expanded system. Allocation will happen at the point of substitution. This is the point where the first commercially valuable product appears in the supply chain. So the impacts of furniture production and of treatment of waste paperboard will be allocated to both furniture and heat. And we will have two activities with two different reference products. One is the furniture and the second one is the heat. We saw in cutoff the classification approach that we follow in order to have the allocation of inputs and outputs. In the case of APOS, we have two different classifications. We have materials for treatment and non-materials for treatment. So in the example of furniture production wooden, the valuable products are non-materials for treatment, and the waste is considered material for treatment because it needs to be further treated. In the database, we have more activities producing the same waste. So more activities where there is a treatment process that produces this valuable product of heat. For example, here we have the flat glass production coated, and in every one of these additional activities, we will need to allocate to two separate activities, one with a reference product, here the flat glass coated, and the second one having a reference product of heat. So when we look at the database and all the more than 19,000 datasets, we have many different activities that produce heat. Here, for example, both activities will produce heat. So what will happen then is that the treatment activity will get the weighted inputs and outputs from all the activities that produce waste paperboard. Here we have a treatment activity getting the weighted inputs from furniture and flat glass production, and also the emissions. And this activity is producing heat that supplies the market for heat. So this, in order to explain it in different words, we have an aggregation of all the activities that produce heat, and we have a data set that has many different inputs and outputs. This data set may be harder to read in the database, especially in the case where it produces municipal waste incineration. So it gets a lot of inputs and outputs from many, many different activities. And in the questions, I see that there is a question about the version 3.9 and APOS. That's a very good question. Why APOS is not included in version 3.9? It's going to be released within this month, within the month of November. So it will be included in version 3.9. So until now, the two system models that we looked at are attributional system models. They look at the here and now, but follow different approaches regarding allocation. Who gets the burdens of treatment? We have a third system model for today, and this is the substitution, consequential, long-term system model. The main modeling assumptions in this system model, in the case of multi-output activities, we have a very different approach here. We have substitution. Byproducts are constrained. They're modeled as negative input, and we are going to look at in more detail. And here we have credits that are given to the reference product for avoided primary production. As we saw in the initial introduction, the byproducts are replacing the need for primary production elsewhere. And what is important here to note is that the markets are supplied by marginal suppliers only, by those suppliers that are able to provide these additional production units. In order to define what are these marginal suppliers, we have some constraints, these three types of constraints. Constraints of byproduct production, constraints due to technology, and constraints due to supply constraint. In the consequential system model, we have less datasets than in the other system models. And this is due to the fact that because of the constraints, because of, for example, technology constraints, some activities that exist in the other system models do not exist in the consequential system model. So let's see here at the three types of constraints and what this actually means. So when you use the consequential system model, how you can evaluate the suppliers of a market. In the undefined database, which is the database that we have as a group of datasets from the data suppliers before any allocation, let's assume that we have two activities that produce silver. We have the gold mine operation, where the main reference product is gold and silver is a byproduct. But we also have silver mine operation. We have silver mines specifically extracting silver. The market for silver is having as a reference product silver, and in the cutoff system model, or in the allocation, the APOS system model, it will be supplied by both activities. However, in the consequential system model, only the silver mine operation can supply the market. And this is because when we have a byproduct, this is considered as constrained production. We cannot create an additional unit. We cannot extract additional silver. If the market asks for additional silver, then the gold mine operation cannot provide this additional unit, because the reason for performing the gold mine operation is gold, is to extract gold. So when we have byproducts, then these activities are not supplying the market. However, the gold mine operation will get a credit. Will get a credit for providing silver, which will not need to be provided by another primary production activity. So there is a credit here, but the market for silver is not supplied by this activity. Another type of constraints is related to technology. Based on the technology, we determine what are the marginal suppliers that can supply that market. Technology can be defined as outdated when the technology is no longer in use. We can have old technology. This is technology that is currently taken out of use as the least competitive technology. Then in the middle, we have current. This is technology in between modern and old. Modern is technology currently used when installing new capacity, and this is considered as the most competitive technology. We also have new technology, which is defined as technically superior in some aspects, but still not commonly installed. So it hasn't reached the market in a great extent yet. From all these technologies, only the modern and new technologies are considered to be able to supply the market in the consequential system model. And this would be translated in the following way. If we have a market data set in the attributional system models, we have supply from all possible producers. Here, for example, we have an old technology supplying with 50% the market, current technology 30%, and modern 20%. In the consequential system model, we will only have modern technology activities supplying the market. The other activities will not provide the products they produce to the market. So in the market for electricity, when you go to the consequential system model and you evaluate the markets for electricity, you will see that the producers are much less than in cutoff, for example. And why this happens? For example, here for France, we have, let's say, 3 producing activities that produce electricity high voltage. One is based on nuclear technology, hydropower technology, and natural gas technology. The first and the second one are considered as modern technologies, while the third one is a current technology. In the cutoff, all these activities will supply the market. In the consequential, the third activity, which has a current technology, will not supply the market. And last but not least, we have the constraints due to supply constraint. Let's consider here the example of chloralkali electrolysis. It's a chemical reaction that produces chlorine as a reference product and sodium hydroxide as a byproduct. As we mentioned, whenever we have byproducts, this activity cannot supply the market. The market for sodium hydroxide cannot be supplied by this activity. If, however, in the database we don't have any other activity that supplies sodium hydroxide as a reference product, then the market for sodium hydroxide is constrained, and this is the modeling assumption that we are following. That means that the market for sodium hydroxide has no unconstrained supplier, and there is no primary production. And this, of course, will affect the consumers of this market for sodium hydroxide. And depending on the case, we may have sometimes substitutes that we introduce. We have, for example, in the supplementary cementitious material, substitutes that we introduce that can substitute a product when the market is constrained. I know that it was a lot of theory today, so the recording and the slides will be available. So you can go back and go more in depth, go more to the section that you're interested in. Now let me wrap up and go again to the main modeling choices and how these are treated by the three system models that we saw today. The two system models, allocation cutoff by classification and APOS, assume a static representation of average conditions. They look at the here and now. The substitution system model evaluates consequences of changes. The two first system models have allocation for multi-output activities. The substitution consequential system model has substitution. Now about the burdens. In the cutoff, there is a polluter pays principle. The waste producer bears the burdens of treating the waste, and the recyclable materials come out burden-free. In APOS, the burdens are shared between products in the value chain. We have a system expansion, and all valuable products in a value chain will get part of the burdens. And in the consequential system model, all the impacts of the burden, all the burdens of the treatment are carried by the waste producer. And finally, the suppliers of the market. We have average suppliers in the allocation system models and marginal or unconstrained suppliers in the consequential system model. Here, just a final remark that I would like to add regarding the burdens of waste treatment. In the allocation APOS system model, since producing valuable products from a waste treatment means that they will get some part of the burden, this system model promotes the creation, the production of valuable materials, of materials that can be reused or recyclable at the end of life. And this slide is just to show you that depending on the system model that you are choosing, you can have very different LCAA scores. This is the method IPCC, the indicator climate change, and let's see, for example, the global warming potential for 100 years. In the allocation cutoff by classification, for the furniture production activity, the impact of the reference product is 0.06 kilograms CO2 equivalent. In the APOS system model is 1.0 7, and in the consequential is almost 2. This difference in the LCIA scores is due to the different assumptions, not only for this specific activity, but for all the activities in the supply chain of furniture wooden. And in this moment, we recommend, for example, if you look at the attributional perspective, to combine the two system models in a sensitivity analysis, which allows you to evaluate the assumptions behind your study and behind the two system models. And with this, I would like to thank you. And let me look at the questions. There is a question. Can you explain what by classification in allocation, cutoff by classification means? Yes. So when we were discussing about the allocation cutoff by classification system model, we saw that the multi-output activities are addressed with we have allocation for the multi-output activities. How does this allocation apply? How is this implemented in the database? Having this classification. So by classification means that we are using the classification of all products to allocatable, recyclable, and waste in order to implement the allocation of multi-output activities. I saw a hand that was raised, and if you have questions, type them in the chat box. Of course, if you have questions after the webinar, feel free to contact us at the support email. We managed to come back to you in just very 1 or 2 days, and we also can have very targeted answers because we have the experts of every sector addressing your question. And with this, if there are no more questions, I would like to thank you for the participation today, for being here, and I wish you a nice day or a nice evening. Thank you very much.